Preparing for AI Retrieval Engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is retrieval-augmented generation, and why is it useful? Retrieval-augmented generation, or RAG, combines search with language generation. I first retrieve relevant documents for a user query, then provide those passages to the model as grounded context. This helps answer questions about private, current, or domain-specific information without retraining the model. A strong implementation also handles chunking, metadata filtering, citations, and context limits. RAG improves factuality, but retrieval quality remains a critical bottleneck, so I evaluate both retrieval and generation separately. While answering, explain retrieval, context injection, generation, grounding, freshness, hallucination reduction, and why RAG is preferable to fine-tuning for frequently changing or proprietary knowledge. Question 2. How would you design an end-to-end retrieval pipeline for an enterprise knowledge base? I would build separate ingestion and query paths. Ingestion parses documents, removes boilerplate, creates semantically coherent chunks, attaches metadata, generates embeddings, and writes records to a vector or hybrid index. At query time, I normalize the question, apply permissions and filters, retrieve candidates, re-rank them, and pass selected evidence to the model. I would add versioning, retries, freshness monitoring, citation logging, and offline evaluation so quality and operational failures are visible. Make sure to cover ingestion, parsing, cleaning, chunking, metadata extraction, embedding, indexing, query processing, retrieval, re-ranking, generation, access control, observability, and evaluation throughout the pipeline. Question 3. How do you choose between dense, sparse, and hybrid retrieval? Dense retrieval captures meaning and handles paraphrases, while sparse methods such as BM25 excel at exact terms, identifiers, and rare keywords. In enterprise search, I usually start with hybrid retrieval because users may ask semantically while documents contain precise product codes. I combine normalized scores or use reciprocal rank fusion, then evaluate recall and latency on representative queries. The best choice depends on corpus language, query patterns, freshness requirements, and infrastructure cost. In your answer, compare semantic embeddings, lexical matching, exact identifiers, vocabulary mismatch, latency, index cost, domain terminology, reciprocal rank fusion, and workload-specific evaluation. Question 4. What makes a good document chunking strategy? Good chunks preserve a complete idea while staying small enough to retrieve precisely and fit within the model context. I prefer structure-aware splitting around headings, paragraphs, lists, and code blocks rather than blindly cutting every fixed number of tokens. I may retain parent document metadata and add modest overlap when references cross boundaries. Chunk size and overlap should be tuned experimentally using recall, answer faithfulness, latency, and token cost measurements. Be sure to mention semantic boundaries, chunk size, overlap, headings, tables, parent-child relationships, token limits, metadata, retrieval granularity, and experiments using measurable retrieval metrics. Question 5. How would you select an embedding model for a retrieval system? I select embeddings by testing realistic query document pairs, not by relying only on leaderboard scores. I compare semantic recall, multilingual and domain performance, vector dimensions, inference latency, memory footprint, licensing, and hosting options. I also check whether the model handles long documents and technical terminology. A smaller model may win operationally if quality is close. Before deployment, I validate performance on hard negatives and monitor drift as content and user behavior change. Discuss domain fit, multilingual support, dimensionality, context length, similarity behavior, latency, hosting, licensing, fine-tuning, benchmark results, and production validation on real queries. Question 6. What is reranking, and when would you add it to retrieval? Reranking improves the ordering of an initial candidate set. A bi-encoder efficiently retrieves hundreds of passages independently, while a cross-encoder examines each query passage pair jointly and usually estimates relevance more accurately. I add reranking when top results contain near matches, competing documents, or subtle terminology. To control latency, I rerank only a limited candidate pool, batch requests, and measure whether the quality gain justifies the extra compute and tail latency. Explain first-stage candidate generation, cross-encoder or learned reranking, relevance precision, latency trade-offs, top K selection, batching, and when reranking improves answer quality most. Question 7. How would you evaluate retrieval quality independently from LLM answer quality? I create a representative query set with judged relevant passages, ideally including difficult and long-tail cases. For retrieval, I track recall at K, precision at K, MRR, and NDCG, while checking whether retrieved evidence actually supports the expected answer. I evaluate generation separately using correctness, faithfulness, citation accuracy, and abstention behavior. This separation tells me whether failures come from missing evidence, poor ranking, prompt construction, or model reasoning. Focus on labeled relevance, recall at K, precision at K, MRR, NDCG, hit rate, answer supporting evidence, query stratification, annotation quality, and separate retrieval from generation failures. Question 8. How do you reduce hallucinations in a RAG application? I reduce hallucinations by improving evidence before tuning the prompt. The system should retrieve authoritative passages, detect whether evidence is sufficient, and instruct the model to answer only from supplied context. I include citations and require an explicit uncertainty response when support is missing. For higher-risk workflows, I add claim-level verification or a second retrieval pass. Evaluation should measure faithfulness and unsupported claims, not merely whether responses sound fluent. Mention high-quality retrieval, evidence sufficiency, grounded prompts, citations, answerability detection, constrained generation, refusal behavior, verification, and faithfulness evaluation. Question 9. How would you handle access control in enterprise retrieval? Authorization must happen before content reaches retrieval results or model context. I propagate the user identity, apply tenant and document permission filters inside the search layer, and avoid relying on post-retrieval filtering alone. Cached results must include authorization scope, and permission changes should invalidate affected entries promptly. I log access decisions without exposing sensitive text, test cross-tenant isolation, and treat retrieved context as protected data throughout the pipeline. Be sure to cover document-level and chunk-level permissions, identity propagation, metadata filters, tenant isolation, security before retrieval, ACL changes, caching risks, and auditability. Question 10. How would you support document updates, deletions, and index freshness? I use stable document identifiers and content hashes so unchanged content is skipped and changed content is reprocessed incrementally. Updates can flow through an event queue into parsing, embedding, and index upsert stages. Deletions create tombstones and trigger removal from every serving index and cache. I version embedding models and schemas, track ingestion lag, and define freshness objectives. For sensitive data, I verify deletion completion rather than assuming eventual consistency is sufficient. Discuss incremental ingestion, stable identifiers, content hashes, upserts, tombstones, event-driven updates, embedding versioning, eventual consistency, deletion guarantees, and freshness monitoring. Question 11. What techniques improve retrieval for conversational or ambiguous queries? Conversational queries often omit the subject, so I first rewrite the latest turn into a standalone search query using relevant conversation history. For example, what about its pricing? Needs the referenced product resolved before retrieval. I may generate multiple query variants when ambiguity is high, then merge results with deduplication and reranking. I preserve the original conversation for answer generation, but keep retrieval focused on a clear, auditable query. In your answer, discuss conversation rewriting, CO reference resolution, query expansion, intent detection, conversation window selection, hybrid search, and preserving the original query for context. Question 12. How would you design retrieval for tables, PDFs, and other complex documents? Complex documents require structure-aware ingestion rather than plain text extraction. I use layout parsing and OCR when necessary, preserve headings, page numbers, table headers, captions, and relationships between sections. For tables, I may store both a serialized representation and searchable cell-level records linked to the source page. I validate extraction quality with sampled documents and retain provenance so generated answers can cite the exact page, section, or table. Mention layout-aware parsing, OCR, table structure, captions, page metadata, multimodal content, parent-child linking, extraction validation, and preserving provenance for citations. Question 13. How do you prevent irrelevant or duplicated chunks from dominating results? I address redundancy at multiple stages. During ingestion, I canonicalize documents and remove duplicate or near-duplicate content. During retrieval, I apply metadata filters, similarity thresholds, and maximal marginal relevance to balance relevance with diversity. I also cap results from one source when several documents repeat the same policy. The objective is not simply more similar chunks, it is a compact evidence set containing distinct, authoritative information. Cover metadata filtering, deduplication, maximal marginal relevance, similarity thresholds, source diversity, canonical documents, chunk identifiers, and measuring result diversity alongside relevance. Question 14. How would you scale a vector search service for high query volume? I would use an approximate nearest neighbor index such as HNSW or an inverted file approach, then benchmark recall against exact search. For scale, I partition by tenant, domain, or time where appropriate, replicate read-heavy shards, and monitor memory closely because vectors are expensive. Query batching, metadata prefilters, and result caching can reduce cost. I would set latency SLOs, test tail behavior, and tune recall, replicas, and index parameters together. Discuss approximate nearest neighbor indexes, partitioning, replication, sharding, memory usage, batching, caching, filtering, tail latency, consistency, and capacity planning. Question 15. What are the main trade-offs between HNSW and IVF-based vector indexes? HNSW builds a navigable graph and usually provides excellent recall and low latency search, but it consumes substantial memory and can be expensive to build. IVF clusters vectors first, reducing search work through selected partitions, and often offers better memory control at large scale, though tuning centroids and probe counts matters. I choose based on corpus size, update frequency, latency targets, and available memory, then validate recall cost curves experimentally. Explain graph versus cluster-based indexing, recall, search speed, build time, memory, update behavior, tuning parameters, and workload characteristics influencing the choice. Question 16. How would you detect and mitigate prompt injection through retrieved documents? Retrieved text is data, not authority, so I explicitly separate it from system and developer instructions using clear delimiters and prompts. I tell the model to ignore instructions contained in documents, restrict tool permissions, and validate outputs before taking actions. I also scan content for suspicious patterns, test adversarial documents, and log injection detections. For high-impact actions, retrieval should inform a human or a constrained workflow rather than directly control tools. Mention untrusted content, instruction data separation, delimiters, privilege boundaries, content scanning, tool restrictions, least privilege, output validation, monitoring, and adversarial testing. Question 17. How would you diagnose a sudden drop in answer quality after deployment? I would first compare retrieval metrics, groundedness, answer correctness, latency, and error rates against the last healthy release. Then I would inspect sampled traces to determine whether documents disappeared, rankings changed, context was truncated, or the model prompt change. I would check ingestion lag, embedding versions, index health, and traffic distribution. A safe response is to roll back or route traffic to the prior version while reproducing failures with a regression set. Be sure to cover metric decomposition, retrieval versus generation checks, data and index changes, embedding versions, latency, prompt changes, drift, rollback, and targeted regression tests. Question 18. When should you use fine-tuning instead of, or alongside, RAG? I use RAG when the challenge is supplying changing or private facts, because the knowledge remains externally updatable and auditable. I consider fine-tuning when the problem is consistent behavior, output format, domain terminology, or task-specific reasoning. Fine-tuning is not a reliable replacement for a frequently updated knowledge base. In practice, I may tune the model to use retrieved evidence better while keeping factual content in the retrieval layer. Discuss knowledge freshness, behavior and style, proprietary facts, training cost, citation needs, catastrophic forgetting, retrieval dependence, parameter-efficient tuning, and combined architectures. Question 19. How would you optimize a retrieval system for latency and cost without hurting quality? I profile the complete path first, separating embedding, vector search, reranking, model generation, and network time. Then I reduce candidate counts safely, cache repeated query embeddings and stable results, batch embedding work, and use approximate indexes. I may apply reranking only to uncertain queries and compress redundant context before generation. Every optimization must be checked against recall, groundedness, and answer correctness, because lower latency is worthless if evidence quality collapses. Focus on pipeline profiling, candidate limits, smaller embeddings, caching, batching, approximate search, reranker thresholds, context compression, precomputation, and quality guardrails. Question 20. Describe a retrieval project you would present in an interview and how you would demonstrate its impact. I would describe the user problem, baseline search behavior, constraints, and the retrieval changes I owned. For example, I might explain how hybrid search, structure-aware chunking, and reranking improved recall at 5 and reduced unsupported answers. I would show an evaluation set, ablation results, latency and cost impact, and production monitoring. I would also discuss a failed approach and the lesson it produced, demonstrating engineering judgment rather than only a successful metric. In your answer, structure the story around the problem, baseline, architecture, experiments, measurable improvements, failure analysis, operational ownership, and lessons learned or next steps. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.